So in exercise 2.2, number 3, it's saying find A in terms of B. So yeah, you're thinking along right. You solve for A, much like solving for any other unknown variable. Um, but when you're dealing with matrices, you do have to be a little bit more careful. Okay, so for A, not so bad, right? If we start off with A plus B equals 3A plus 2B, we can simply subtract 3A from both sides, right? Because there's no problem adding, subtracting matrices. And then we could subtract B from both sides, right? Okay, well, let's subtract B. And that would be negative 2A equals B in this case. And then we could multiply by the negative 1/2. And that would give me A, no problem, right? Okay, so where you need to be careful when solving equations with matrices is when you have to divide, I say that very loosely, by another matrix. So let's say for a second we had something like 2A equals just something really simple, AB. Okay? The problem is you can't just divide by a matrix. You would have to multiply by its inverse. Okay? Um, and since on this side, if I'm trying to get rid of the A, and A is on the left, I have to multiply by the inverse on the left. Okay? Now, those two would cancel out, and that would be left with, and that's a scalar multiple, so I could always do, something like, 2 times A inverse times A, and this side, the A inverse A. But the A inverse and A's, those equal the identity, right? So that's 2 times the identity matrix. It's not just 1, right? Would be equal to B. Okay? But you got to be careful if you're multiplying things on the left and on the right, because matrix multiplication is not commutative. Okay? So we need to be extra careful about that aspect of it, if that makes any sense. Okay? Now, your other question was about number 5, and what is it asking? It's asking you to show that this is actually true. Okay, so if you started off with any 2 by 2 matrix, okay, like this, is it equal to A times 1, 0, 0, 0 plus B times 0, 1, 0, 0 times 0, 0, 1, 0. And I'm scrolling around accidentally there. Okay. And the answer is, of course, it's just writing out, in making sure your scalar multiplication, oh, well, A times that would be this matrix. B times that. Remember, with the scalar, you just multiply every entry in the matrix by that scalar. So if I do this in several steps here, and that's supposed to be a 0, even though it looks not like a 0. And now when you add matrices, you just add, all of the corresponding rows and column, entry stuff. So A plus 0 plus 0 plus 0 is A. 0 plus B plus 0 plus 0 is B. 0 plus 0 plus C plus 0 is C. 0 plus 0 plus 0 plus D would be D. And sure enough, those two sides are equal, so we have just shown that you could write the matrix ABCD as the scalar multiples of things. Okay, we can kind of decompose it into those. So it's just a skill, actually, that we're going to use later, being able to decompose and break up vectors into these constituent parts, and we're just using matrices to do that right now, so it's just a practice with the skill. Okay, and I know you said you didn't need the answer explicitly, but I wasn't sure how to give you hints without actually doing it. Okay. So hopefully it helps, and please don't copy it down. And if you have any questions about it, of course, ask me for some clarification or something. I'll be happy to help you out. And have a wonderful day.